This lesson shows how to graph the rational function -3 over x. In previous lessons, you've learned about the four important parts of a rational function. The vertical asymptote is a vertical line where the function is not defined. The graph curves up or down as it approaches its VA. The horizontal asymptote is a horizontal line. The graph approaches away from the VA, curving down from above or up from below. The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the graph crosses the x-axis. This lesson shows how to graph the rational function y equals -3 over x and variations of the function. The VA is the zero of the denominator. Set the denominator equal to 0 and solve. The VA for this function is the vertical line x equals 0, the y-axis. For this rational function, the numerator is degree 0 and the denominator is degree 1. Since the degree of the numerator is less than the degree of the denominator, the HA for this function is the horizontal line y equals 0, the x-axis. To find the y-intercept, evaluate the function for x equals 0. Since the function is not defined at x equals 0, there is no y-intercept. The x-intercept is the 0 of the numerator. Since the numerator is a constant, it can never be 0, and there is no x-intercept. Next, calculate at least one point on either side of the VA. At x equals -1, y equals +3, and there's a point at -1, 3. At x equals 1, y equals -3, and there's a point at 1, -3. From this point, the graph can't curve down towards the VA because there would be an x-intercept, so the graph must curve up towards the VA and down from above towards the HA. And from this point, the graph can't curve up towards the VA because there would be an x-intercept, so the graph must curve down towards the VA and up from below towards the HA. So sketch the graph of the function like this. Here are some variations of the function. If the constant in the numerator is changed from -3 to +3, the graph is vertically reflected. For example, notice this branch of the graph is flipped over and is now in the first quadrant. If the constant in the numerator is larger, the graph stretches vertically. For example, notice this branch of the graph is higher. If the constant in the numerator is smaller, the graph shrinks vertically. For example, notice this branch of the graph is lower. If x in the denominator is replaced with x minus 2, the graph shifts to the right. The VA is now at x equals 2. If x in the denominator is replaced with x plus 3, the graph shifts to the left. And the VA is now at x equals -3. This lesson showed how to graph the rational function -3 over x. And this lesson was brought to you by the Math Fun Academy. Its continuing mission to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.